Chapter 1b is all about quadratic functions. In Lesson 1.4, we'll look at solving and graphing and writing equations for quadratic functions. 1.4 Day 1 will focus on solving. We'll tie in some of our content that we did in Chapter P at the beginning of the school year. A quadratic equation is in standard form when it models a times x squared plus b times x plus c. Now that can equal f of x, it can equal y, it can equal 0. Anything of that form would be in standard form for a quadratic. The most common method for solving is trying factoring. When you factor, you always want to set your equation equal to 0. Then factor completely, including common factoring, including trying to just break apart c, or doing that earmuff method where we multiply a times c and split to get b. Once you've factored your equation completely, then what you want to do is apply what's called the zero product property. Let's try a couple of examples. In our first equation, we have 6x squared minus 3x equals 0. So it's already set equal to 0. We just need to factor completely. Now this doesn't have the three terms that a normal standard form would have. It just has two. We can't split it apart then into two parentheses because it doesn't have that last term. If you look at 6x squared and 3x, they have something in common. We could factor both a 3 and an x out of both of them. If we do that in that first term, we would have 2x left over. And in that second term, 3x would cancel itself out, leaving 1. Once you've factored completely, here's what we mean by the zero product property. Take the outside and set it equal to 0. Take the inside and set it equal to 0. Those are the two locations on the x-axis where we'd have an x-intercept. And now just solve for x. In that first kind of smaller equation, I'm just going to divide both sides by 3. And 0 of the function is x equals 0. In the other equation, I'll add 1 first, and then we have to divide by 2. Oh, and there's my cat Diesel showing how excited he is that we're finding x-intercepts. There's our other solution. At x equals 0 and x equals 1/2 would be where it crosses the x-axis. Let's try another one. X squared plus 8x plus 16. In this case, let's try to factor 16 in such a way where we'd have two numbers that multiply to get 16, but add to get positive 8. Well, that's going to be 4 and 4. As we split this quadratic and set each part equal to 0, the x squared would separate into x times x, and 16 would break down into positive 4 times positive 4. Notice the x-intercepts are the same, or the parentheses are the same, so we only need to set one of them equal to 0. You wouldn't have to solve it twice, because you'd get the same answer. This means this quadratic only has one x-intercept at -4. We'll save that last question on the right for class tomorrow, but let's try the next set of problems. Here's a new method for us. It's other than factoring, but it allows us to get x by itself. It's called extracting square roots. And that sounds kind of weird, but it's a pretty easy process to follow. If you're going to extract square roots, what you want to do is isolate just the x squared term. So that means you can't have a plain x term like we had up above. You can only have an x squared in your equation. Once you isolate it, then what you're going to do is take the square root. So that's kind of the game plan. Let's take a look at that first example. X squared equals 49. Fair enough, this is a quadratic equation. X squared is already by itself. What I'm going to do is take the square root of the left and the square root of the right. Here's what makes this solution unique. The square root of 49 has two possible locations, positive or -7. So there are two different solutions. That means it would cross the x-axis on the left side at -7 and on the right at +7. Now in that next example, we have 4 times x squared is equal to 12. To isolate the x squared term, we have to actually divide by 4 first. That leaves us with x squared is equal to 12 divided by 4, which is 3. And now when we take the square root, that would give us plus or minus the square root of 3. That's your exact answer. If we were actually going to graph, the square root of 3 is about 1.7. But you guys know how we actually do things. We always keep it exact unless we're going to graph, which that's going to happen eventually. But this is the answer we're looking for now. Now this last one is also unique because it doesn't have just x being squared. It's x minus 1 squared. This is an example where we have to get rid of the squared first, even though the 1 is with the x, but it's on the inside. If I square root both sides, that cancels out with the 2 and we just get x minus 1 on the left-hand side. On the right, the square root of 10 becomes plus or minus the square root of 10. And now to get x by itself, we have to add 1. But detail matters here. If we add 1, what's going to end up happening is we have to put that first and then put plus or minus the square root of 10 after. This actually means 1 plus the square root of 10 is one x-intercept, and 1 minus the square root of 10 is the other. And now it's time for everybody's favorite method in solving a quadratic equation, the quadratic formula. If you have all 3 terms or you know what the coefficients are for all 3 terms, this fraction rule will always tell you what your answer is to a quadratic function. Finding the zeros, finding the x-intercepts. That all means to do the same thing. The trade-off is it's tricky to simplify. So I encourage you to just take your time, watch your steps, and try not to do too many steps at one time. Let's try a couple of these and then we'll do the last one in class tomorrow. So solve using the quadratic formula. Our first equation is x squared plus 3x minus 9 is equal to 0. Now the coefficients for a, b, and c come from the numbers in this equation. A is going to be the number in front of our lead term, which in this case would be 1. B is positive 3, and c is negative 9. If we plug just those coefficients into our equation, it's going to look something like this. X equals negative b, which would be negative 3, plus or minus the square root of b squared minus 4 times a times c, and notice c is negative, all over 2 times a. As we simplify, work inside out with your square root. Negative 3 plus or minus. Now watch this. On the inside, 3 squared is 9. But then if you have minus 4 times 1 times negative 9, this double negative would actually change to positive. There we go. And then you have 4 times 1 times 9, which is 36. All over 2 times 1, which is 2. Now 9 plus 36 is going to be 45. And here's where we have to be careful and not just grab our calculators right away. I want the exact answers unless we're sketching a graph. Then we can use decimal approximations. Now 45 is the same as the square root of 9 times 5. And what does the square root of 9 equal? That's 3. So that's the same as 3 times the square root of 5. If I write that in place of the square root of 45, we have negative 3 plus or minus 3 square root 5 all over 2. Now that fraction would reduce if all the numbers on the outside had a common factor, but in this case they don't. This is our exact solution set for the x-intercepts. Let's try one more and then we'll call it good. 3x squared plus 2x equals 10. Well, the first thing we need to do is put it in the correct form for solving. We need to set it equal to 0. The easiest way to do that would just be to subtract 10 to the other side. That gives us 3x squared plus 2x minus 10 is equal to 0. What I'd like you to do is plug it into quadratic formula and simplify. That'll be your homework, and we'll check it tomorrow in class.